Hello, prob stats, and welcome to 12.2. This is a two-way ANOVA, so I'm hoping you're understanding that instead of having one thing to look at, we're going to have two different categories that are going to decide if there's an interaction between. It's like gender and age is the first ones we're going to do. All right, make sure you got stat disc up and your notes, and let's go. All right, two-way ANOVA this time instead of a one-way ANOVA. There's going to be two-way analysis of variance. We're going to look at the interaction between two factors, the row factor and the column factor, just like last time. The first example we're going to use is an age bracket and a gender. And if you look here, I used ages as my rows and gender as my columns. Now when you go through here, you're going to do a two-way analysis of variance, and we have to type in our data, which I want you to do above before we get going. I want to show you how you do this because you don't do it like we have normally done in the past. So when we go here, your two-way analysis is 0.05. You do not go to your stat disc online and put it into your data set. It will not work. You have to go to analysis, two-way analysis of variance, 0.05. You want 3 rows and 2 columns. And I want 10 values in each cell. So now when you look at this, what they've done, now you've got to fill in here this third column, hopefully. All right, so like here, it goes row 1, column 1. Well, in row 1, column 1, I have these 10 values, so make sure you enter them. And as you go down, the next 10 are, well, there we go. Now it goes row 1, column 2 are the next 10, and then row 2, column 1. And you're entering all of your data in here like so. You cannot enter it in any other way. You have to get it generated by this table. So 0.05, 3 rows, 2 columns, 10 in each, generate table, then type it into the value. Okay, pause and get that done. Now, if you look at the bottom, we got these test statistics is what we're going to be looking at. I've already copied those onto your notes for you. So let's go back and see what we have. So yeah, you've entered this in. You do realize it's different than it's been before. It's the first time we've ever done it this way. Our test statistics are here. And again, we're going to be looking at the normal things, our test statistic and our critical values for interaction, the rows and the columns. And we will also be looking at our p-values. All right, I'm hoping you know, like, nothing has changed. So like when the P is low, the null must go. So the only one we're going to reject is the column one. The other two are going to have interactions. So we're going to look at interaction between the two factors. If the effect of one factor changes for different categories of the other factors, what we're looking at. Now, some of the things I want you to look at that we have to construct and make sure that they work before we can go. The data with means of and an interaction graph. You have to calculate the mean for each cell. So I've done the first 4 cells for you. So now I want you to calculate the mean for the females between 50 and 80 and the mean between male between 50 and 80. So type those 10 in and divide by 10, and what do you get? So pause and get that done. All right, when I did this, I got 80.4. And the other one, I got 67.2. Now, if you look, it looks like it varies quite a bit. We have a high of 64, and a low of 64 and a high of 82. So there's a considerable variance. Now we got to figure out what it deals with. The next thing I want you to do is go into sheets. So your data sheets, I want you to insert a chart. So I want you to type these values into sheets and create a line graph is what I would like you to do. So show you what that looks like. Whoops. Here we are in sheets. I've typed in my values. Now, when you first put these in, you're going to go to insert, insert chart, and it comes up with a bar chart. Well, I don't want a bar chart, so you got to click on hold on, let's not do this. Sorry about that, I forgot a step. Okay, the first thing you need to do is highlight your data. Then you have to go to Insert, will stay. Insert, chart, and it always comes up with the bar chart first because that's the first one on the thing. Go over to your side where it says column chart, click on that. We would like a line chart on the bottom, so click there, and there's your line. Now you're going to evaluate this and see if it's fairly parallel. I know it doesn't look like it, but our data is very squished together from like this are 25 points between these two. That's just quite a bit. If you put these out into single ones, they are actually not far from parallel. So we're going to go with yes, they are. So let's get back to our notes. So right now we're looking for an interaction effect, and we look at our graph with our means. Suggest that the line segments are far from being parallel if there is an interaction effect. There's no effect if they are parallel. So if we had taken this and this here had gone like so, like crazy, all right, then there's an interaction effect because they're far from parallel. But ours are actually not too far off, so there is no interaction. So ours is no interaction because they're close to parallel. Right? There does not appear to be an interaction effect for our graph, and that's what we're looking at. So that's what we're going to start with. So next, your objective, you're going to look for an interaction between the row and the column. We're going to look at just row factors and just column factors. So just the male or just the female, or does it go between ages, or is it a combination of both? Now let's go here. Requirements, these must be met. Normal, so you have to check normality for each cell. All right, so you have to type each cell in, check for normal. When you do so, you'll see that they all approximate a line. The variations have to be the same for each cell. All right, sampling, are there random samples? They have to be independent. They do not worry about each other. There has to be a two-way, so we have two categories, which we have. And the last, which is new, it's a balanced design. All the cells have to have the same number of values. If they do not, you cannot do this. They have to be balanced for a two-way ANOVA. Interaction effect is where we're at now. Two-way analysis of variance, you test the null hypothesis that there is no interaction between the two factors. So we're going to use the p-value corresponding to the test statistic. Now we're going to reject if the null is low. We're going to fail to reject if the null is high. That has never changed. Next, step 2, we're going to look at the row and the column effect. All right, and the same thing is going to be true. If we conclude that there's an interaction effect, then we should stop now. We should not proceed with the 2 additional tests. If there is an interaction between the factors, we shouldn't consider the factors themselves individually. All right? We conclude there is no interaction effect, so there is no interaction effect, then we should proceed. So this number 1 has to be true. Okay, row factor. Test the null hypothesis. If there is no effect from the row factor, is the null, and the same is true for the column factor. The null is there are no effects from the column factor. And we reject again when they are low. Okay, here we are. Given the pulse rates, this is what we have. We're going to look at our test statistics. Okay, for each cell, the sample values appear to form a population with a distribution that is approximately normal. So when I type in my cells, and you have to do all 6 of them, I did female 18 to 29. It's a little off, but it is not terrible. Okay, we do 18 to 29, 30 to 49. That one's really good. And we do them all. And remember, we've only got 10, so our lines are not going to look the best. Okay, variances are very different. So if we look at our variances and we had to go with this and this was strict, we'd have to stop. But variances are not robust. So since they're not robust, I can continue. The samples are a simple random sample, which is true. They are independent of each other, which is true. We have 2 categories, which are age and gender. And we have 10 values in each cell. So all of our requirements are met. Next, now let's look at our solution set. So we're looking at our data that we collected earlier from StatDisk. I retyped it in. I'll actually recopied it in here for you. So step 1, interaction effect. We test the null hypothesis. Okay, so the null hypothesis is that there is no interaction between the two factors. Okay, so we get the results, and the F statistic is 0.9. All right. 0.9 is less than this. It is not in a critical range. We fail to reject the null. Okay, so since our null was there was no interaction, we fail to reject that, so there is no interaction, which is good. We can continue. You can also look at the p-value, which is the same. Not the same result. 0.39 is greater than 0.05. Again, we fail to reject the null. So there's no interaction. There's no interaction. We can continue. If there is interaction, we are done. Okay, so what this means, it does not appear that the pulse rates are affected by interaction between age and gender. All right, so that's good. So the pulse rates are not affected by those two together. Okay, row effect. Again, the null, there's no effect from the row factor. And the null for the column is there's no effect by the column. So let's look at the row factor. 0.17 is greater than 0.05. We fail to reject the null. So that means there is no effect by the age bracket. So the age doesn't matter. Here, though, the p-value is less than, so we reject the null. So we reject the null hypothesis, which means the pulse rates do appear to be affected by gender. So males and females are different, is what this is saying. Okay, so we conclude that pulse rates appear to be affected by gender, but not by age bracket, and not by an interaction between age bracket and gender. Pretty cool, right? All right, now yours. I would like you to explore, so pause and type this in and see what you can come up with. Don't forget to do your requirements. Okay, after you typed it all in, I hope you got these here for your sources. If you look, every p-value is above 0.05, which means that every single one of these here fails to reject the null, so none of these have an effect, is what you should have concluded. All right, when you were here and you were looking at your requirements, it was really hard because there's only 2 of these. Since it's hard, I mean, whoops. All right, your first requirement, that it's normal. It's hard to tell because you've only got 2, so we're going to assume yes because we can't say no. Your second was your variances. Again, ridiculously hard, but no one cares about this. It doesn't have to be robust. 3, they were random, which was good. 4, they were independent. One card does not depend on the other. 5, we have 2 categories, which is true. And 6, everybody had 2 values per cell. So it was distributed well. So our requirements were met. Now, once you looked at your sources, we found that all 3 p-values were greater than 0.05. So that meant that all 3 failed to reject the null. And since all 3 failed to reject the null, that means none of these are, fuel consumption does not appear to be affected by any of these. So you would say fuel consumption, just write the first one. Does not appear to be affected by engine type and size, or by the interaction between engine type and size. should put that in here, interaction between. And then the second one also does not, fuel consumption does not appear to be affected by engine type, and fuel consumption does not appear to be affected by engine size. So this one here was not quite as much fun. Okay, good luck on your homework. I hope you do well. Make sure you post questions.